In this example, we are given a function that describes the position of a particle along a linear path at any given time t. And we are going to use calculus to explore the motion of the particle. So there are many things that we can ask about the particle's movement. And one of the first things that we might ask is, what is the velocity of the particle? And so the velocity is going to be the change in position over time. So we're going to start there. So we're going to start with giving the velocity function. So the velocity is going to be the change in position over time. So that is really the derivative of position over time. So this is a polynomial, so we're going to use just power rule. 3t squared minus 12t plus 9. Okay, so we'll use this to find the velocity at 2 seconds and at 4 seconds and give an interpretation of those velocities. So the velocity at 2 seconds is 3 times 2 squared minus 12 times 2 plus 9, which is -3. So stop and think a little bit about what it means that the velocity at t equals 2 equals -3. And see if you can formulate a response to this using units, keeping in mind that f is given as the position function where t is measured in seconds and f of t is measured in meters. Okay, hopefully you came up with the statement that at 2 seconds, the particle is moving backwards at a speed of 3 meters per second. So the backwards is connected to that negative velocity. Now the velocity at 4 seconds, v of 4, is 3 times 4 squared minus 12 times 4 plus 9. That is 9, positive 9. So at 4 seconds, the particle is moving forward. Why forward? Because the velocity is positive at a speed of 9 meters per second. And I just want to remind you about these units. The velocity is the change in position over time, where s is your position function. For some reason, calculus, we like to use s as position. And the units for s are meters, and the units for t are seconds. Okay, so it's meters per second. Next question, at what times is the particle at rest? Think for a minute about what that means. Hopefully you came up with the particle is at rest when velocity is equal to 0. So we're looking for when velocity equals 0. Okay, now my velocity it was 3t squared minus 12t plus 9. So I want to solve where velocity is 0. So I'm looking for 3t squared minus 12t plus 9 equals 0. Let's go ahead and factor a 3 out of here. 3 times t squared minus 4t plus 3 equals 0. Okay, so we can factor that further. So we have 3 times t minus 1 times t minus 3 equals 0. That tells us that t equals 1 or t equals 3. So that tells us that the particle is at rest at 1 second and at 3 seconds. And I do want to take a minute to just address this idea of at rest. This means that for a split moment, the particle is neither moving forward nor backwards. It's for a split moment, it is not moving. And that does not mean there's that it pauses and it rests. So at rest just means the velocity is 0, and there may or may not be any rest there. Okay. When is the particle moving forward and when is it moving backward? So if you want to think about what this is asking about, moving forward means the velocity would be positive. The velocity is positive, and moving backward, the velocity is negative. Take a moment. Here's our velocity function up above. Think about how you would figure out when the velocity is positive, when the velocity is negative. So I'm going to look at v by its factored form. So v of t is 3 times t minus 1 times t minus 3. And I know that v is 0 at t equals 1 and t equals 3. So I can kind of look at a number line. Here's 1 and here's 3. And if t is less than 1, then t minus 1 is going to be a negative number. And if t is greater than 1, then t minus 1 is going to be a positive number. So I'm going to just keep track of t minus 1. It's going to be negative to the left of 1 and positive to the right of 1. And t minus 3, if t is less than 3, then that quantity is going to be negative. And if t is greater than 3, then that quantity is going to be positive. So then velocity is the product of 3 and t minus 1 and t minus 3. Since 3 is a positive number, it's not going to affect the sign here. So this tells us that to the left of 1, v of t is going to be 3, which is a positive number, times a negative number times a negative number. So it is overall going to be positive. If t is between 1 and 3, then it's going to be the product of 3 and a positive number and a negative number. So it is going to be negative. And if t is greater than 3, then v is going to be a product of 3 positive numbers. So it's going to be positive. Okay. So this tells us that the particle is going to be moving forward. Keep in mind, it's where the velocity is positive. And so it's going to be for t less than 1 and t greater than 3. So I'm starting at 0 seconds. In practicality, I kind of don't really acknowledge what happens before time 0. So I'm going to say the particle is moving forward for the first 1 second, and then moving backwards from 1 second to 3 seconds, and then it's going to be moving forward after 3 seconds. All right, next thing. When is the particle speeding up and when is it slowing down? This is a bit of a tough question. And you need to think about what it means to be speeding up. Okay, so speeding up means it is going faster in the direction that it is moving. Okay. So you might already understand that speeding up means an acceleration. Now, in casual English, we have a notion of acceleration as meaning speeding up. But in math and physics, we talk about speeding acceleration is really just a change in velocity. So that's the definition of acceleration. Acceleration is a change in velocity over time. And I'm going to write that acceleration is the change in velocity over time. It's the derivative of velocity over time. So thinking about what acceleration means, think a minute about what positive acceleration means versus what negative acceleration means. I'm going to give some silence for this. So positive acceleration means that the velocity is changing to be more in the positive direction. Now, if your velocity is positive, that means you are moving forward, and you have positive acceleration, then that means you would be moving forward faster. You would be changing your velocity to be more in the positive direction. So that would be a version of speeding up. Now, if the velocity is positive and the acceleration is negative, acceleration is negative means you are moving the velocity more towards the negative direction. Now, if the velocity is positive and you're moving it to be more in the negative direction, it is becoming a smaller positive number. So are you speeding up or are you slowing down? So the particle is slowing down. So what if the velocity is negative? Okay, so if the velocity is negative and the acceleration is positive, that means you are changing the velocity to move towards the positive direction. Now, the velocity is negative means that you are just moving backwards, but you're moving the velocity towards moving forward. That must mean that you are slowing down. So if the velocity is negative and you're moving toward the positive direction, you're becoming less negative. It's becoming a smaller and smaller negative number. So I'm just going to not summarize that with all of those words. You are slowing down. And finally, if the velocity is negative and the acceleration is negative, acceleration is negative means you are moving the velocity to be more in the negative direction. You are decreasing the velocity. And that's not the same as decreasing the speed. You are moving the velocity to be more towards the negative direction. If it's already negative and you're moving it more towards the negative direction, then it's becoming a bigger negative number, which means you are speeding up, going backwards. Let's actually put that note in here. In this case, velocity is negative and acceleration is positive. You're slowing down and going backwards. In this first case, your velocity is positive, so you're going forward, and your acceleration is positive, so you're going forward at a faster rate. So you're speeding up, going forward. And in this case, velocity is positive and acceleration is negative. You're slowing down, going forward. Okay. So looking at this, you can summarize as this particle is speeding up if the velocity and the acceleration have the same sign. If you are going forward and you are accelerating in the forward direction, that means you're speeding up. If you're going backward and accelerating in the backward direction, you are speeding up, going backward. And if your acceleration and your velocity have opposite signs, then you are going to be slowing down. So one of the things we need to do here is we need to calculate the acceleration. which is the derivative of velocity. So let me just rewrite this. The velocity is 3t squared minus 12t plus 9. So the acceleration is going to be the derivative of velocity, which is 6t minus 12, which is 6 times t minus 2. So the acceleration is 0 at 2, and if t is less than 2, then the acceleration is going to be positive. Sorry, if t is less than 2, then the acceleration is going to be negative. If t is greater than 2, then the acceleration is going to be positive. So let us kind of put in this line. We have t equals 2. That's our break for when acceleration equals 0. And the acceleration is positive to the right of 2, and the acceleration is negative to the left of 2. Okay, and we also had the other markers that where velocity changed sign, and that was at 1 and 3. So we had the velocity was positive to the left of 1, and the velocity was negative to between 1 and 3, and the velocity was positive to the right of 1. So we have basically 4 different regions now. Here we have velocity is positive and acceleration is negative. So that means we're moving forward and accelerating backwards, which means we're slowing down. Between 1 and 2, my my velocity is negative and my acceleration is also negative. So because my velocity is negative, I'm moving backward. And because I am moving backward and also accelerating backward, that means I must be speeding up. Between 2 and 3 seconds, my velocity is negative and my acceleration is positive, so I'm moving backward. I'm moving backward and accelerating forward, that means I must be slowing down. And then for t greater than 3, my velocity is positive and my acceleration is also positive. I'm moving forward and also accelerating forward. That means I must be speeding up. All right. Next task. Draw a picture of the path traveled by the particle during the time period from t equals 0 to 8. So one of the things that we got here is that the particle is going to be, we saw that the particle is moving forward for the first second and then backward for the next 2 seconds and then forward for the, for forever after 3 seconds. So we can kind of go, well, it's going forward and then backward and then forward. And, you know, I'm going on some linear path. You can't really see what my path is if I actually draw it all on the same path. So I'm going to kind of lift off that path to be able to see, like, I go forward and then backward and then forward. So I don't know how far I go backwards. I don't know how far I go forward, but I kind of know at t equals 0, I'm going forward. At t equals 1, I turn around and move backward. And at t equals 3, I turn around and move forward, and I'm moving forward forevermore. So that is a rough idea just based on my answer to part D. Okay. And we need to get a little bit more particular, like what is the position of the particle at these little marker points. So we need to know the position at t equals 0, at t equals 1, and t equals 3. So we need to know the f of 0, f of 1, and f of 3. So let's remind ourselves, f of t is t to the third power minus 6t to the second power plus 9t. So we get f of 0 equals 0, f of 1 equals 4, and f of 3, let's see, that's 27 minus 54 plus 27. That's 0. Okay, so that actually tells us a little bit more concretely. If I put up a scale here, and it says for the first 8 seconds. So let's also find out what is f of 8. Oh, 8 to the third power. I'm just going to use a computer to do this. 8 to the third power minus 6 times 8 squared is 64 plus 72 is 200. Okay. This is pretty far off my scale, so I'm just going to kind of say f of 8 is 200. It's way up there. And I am going to put my markers here. I'm going to put a 0 here, and it looks like I go up to 4 and back to 3, so I'm going to do 1, 2, 3, 4 like that. So if I kind of mark what my path is, I start out at 0 at t equals 0. And then for the first 1 second, I go up and I go to 4, and then I turn around and go back. And then for the next 2 seconds, I travel back to 0. And so this was at t equals 0. Here at t equals 1, I am at t equals 1, I am turning around and traveling backwards, and then I go at t equals 3, I turn around again, and I move forward, and then I am moving forward forevermore. Okay, and we also saw that for the first 1 second, the particle is slowing down. And then from t equals 1 to t equals 2, the particle is speeding up, moving backwards. And then at t equals 2, it starts slowing down, which makes sense because it's getting ready to turn around. And then after t equals 3, it starts speeding up. Okay. The last thing is the total distance traveled by the particle during the time period. Now, you might be tempted to say, well, it's 200 meters because f of 8 is 200 and f of 0 is 0. And that is not the total distance traveled, because as you see, we have, we went forward and then backward and then forward again. So those first 4 meters were actually counted 3 times. Okay. So what we actually need to do in order to ask the question, what is the total distance traveled? We need to find out when the particle is moving forward and when it is moving backward and calculate all of the distances traveled during those individual movements. So I'm going to kind of record these. So we going from 0 to 1, we go forward 4 meters, and from t going from 1 to 3, we go backward 4 meters, and then from t equals 3 to 8, we're going to go forward 200 meters. So we had a total of 208 meters. So something that's kind of interesting about this is we took this function that describes the position of a particle, and we had this kind of blind walk, like we didn't know how this position was changing. And we used the calculus to kind of dissect one piece at a time, taking the derivative and looking at the velocity and finding out when is the particle moving forward and when is it moving backward. And we could have actually drawn this picture based off of that. Like, when is the velocity 0? When is it positive and negative? And we could have actually drawn this then. And then asked the question of when is it speeding up and when is it slowing down. That kind of refines our understanding of what is actually happening at each of those chunks of time during the travel.